Number 20. Okay. It wants to know the perimeter of this guy here. We want to know his perimeter distance around him. The only thing we have on the smaller guys, he's 6. Now, it does tell us that they're similar. And if two triangles are similar, all their sides grow at the same rate, their altitudes grow at the same rate, everybody's going at the same rate. So we got to be careful here a little bit, though, because notice it's 50, 60, and down here's your 70, here's your 50, 60, and up here's your 70. So the triangles have been turned a little bit. So we got to be a little careful. So no big deal. We're going to set up this 6 corresponds with who over there? Well, the 6 is between 50 and 70. 50 and 70 is who? 12. As the perimeter of this, which we don't know, corresponds to the perimeter of this triangle. What is this guy's perimeter? Well, 8 plus 10 plus 12 is 30. He is 30. Okay. So you probably can guess what the answer is. If he's 30 and you notice you went from 6 to 12, you doubled, that perimeter is going to be 15 because 15 doubled is 30. But let's do the math to it. So we would go, okay, let's do the means extremes. 12 times the missing perimeter equals 30 times 6, 180. Let's divide by 12, divide by 12. And yes, we get a perimeter of 15. Now, if worse came to worse, you could set things up. If you like, oh, I don't remember how to do that. You could come in here and you could say, hey, 6 corresponds to 12 as this missing side corresponds to, in this case, the 10, and get his measurement, whatever his measurement is. And then you could do the same thing and then get his measurement, and then you could just add them up. But that would take quite a few extra steps and doing the problem twice. So this method, knowing what you're doing, is much more important. But if worse came to worse, you could do that.